In modern AI development, there is a single, uncompromising bottleneck: compute. The sheer volume of processing power required to train a frontier model is so scarce that the world's leading labs typically operate on multi-year release cycles. XAI is currently operating as a structural anomaly in this landscape, attempting to compress several years of standard development into a matter of months. This chart plots model parameter count against time to show the trajectory of their current roadmap. Starting from a 500 billion parameter baseline, XAI is executing rapid jumps to 1 trillion and then 1.5 trillion parameters. That trend line then shoots aggressively upward toward a 10 trillion parameter node, Grok 5. This 10 trillion parameter node is designed to reach the threshold of artificial general intelligence. Success for XAI would prove that brute force scaling can successfully overpower standard hardware constraints and accelerate the timeline to AGI. Elon Musk recently detailed a specific near-term timeline for this model, an aggressive public roadmap that demands technical scrutiny. XAI is testing the hypothesis that sheer parameter scaling yields general intelligence. This strategy deviates from academic standards that suggest intelligence requires more than just increased scale. This investigation will deconstruct XAI's parallel training topology, map the Grok 5 escalation timeline, and stress test this strategy against formal cognitive rubrics. Analyzing this roadmap clarifies whether AGI is an engineering problem solvable with hardware, or if it requires a different approach to cognitive architecture. Most legacy developers rely on a sequential training methodology to build large language models. This diagram shows the standard industry method. One model generation must completely finish its progression through the compute bottleneck before the next generation can begin its training run. XAI uses a Colossus topology to bypass this restriction. In this setup, a central compute cluster splits its output into multiple simultaneous parallel training lanes. Current data drops indicate 7 distinct models are drawing compute from this cluster simultaneously. The cluster is currently training dual 1 trillion parameter architectures, 2 1.5 trillion variants, vision models, and the 6 trillion and 10 trillion parameter giants. This topology allows for simultaneous A/B testing of different model architectures at a massive scale. Parallel training allows XAI to iterate across generations in months, hunting for frontier capabilities without waiting for previous models to finish their cycles. Running 7 frontier models concurrently requires massive hardware resources that would typically cause resource starvation for a younger lab. XAI leverages an integrated network. Tesla provides GPU clusters, X supplies global data distribution, and SpaceX provides the engineering talent. This network enabled the rapid deployment of the Colossus supercomputer, the physical engine designed to execute this parallel strategy. By decentralizing infrastructure across these companies, XAI has insulated its development from the compute shortages currently affecting other developers. The chronological roadmap identifies Grok 4.3 as the beta transition point, before the major scale jumps begin. This Gantt chart shows the rapid escalation planned for the coming weeks. Grok 4.4 doubles the baseline to 1 trillion parameters, followed quickly by Grok 4.5 at 1.5 trillion. The 10 trillion parameter Grok 5 has a specific 2-month window dedicated to its pre-training phase. Pre-training is only the first phase. The model must still undergo post-training alignment, safety evaluations, and inference optimization. These required steps push the realistic public deployment of Grok 5 toward the end of the year. This concrete schedule establishes the 10 trillion parameter model as an active pipeline, currently consuming massive resources. The physical reality of this pipeline brings us to the core controversy: the direct association of the 10T model with artificial general intelligence. Many professionals are skeptical that parameter volume is a direct proxy for general reasoning. This is known as the parameter fallacy, the unproven assumption that scaling standard architectures will inevitably result in human-level intelligence. Reaching AGI requires verifiable intelligence and the ability to solve novel problems, rather than just superior statistical next-token prediction. Cross-domain competence is the only way to prove if a 10 trillion parameter model is actually intelligent or simply incredibly large. To measure this progress, we can apply the formal standards for AGI established by Google DeepMind. This rubric defines AGI as a broad, multidimensional cognitive profile rather than a single benchmark. This includes long-horizon reasoning and complex episodic memory retrieval. It also requires adaptive problem solving in novel environments and the ability to learn continuously across domains. We're testing if an autoregressive architecture can fulfill these specific cognitive requirements through scaling laws alone. Passing this test requires Grok 5 to perform at human parity across all these domains simultaneously. XAI has staked its infrastructure on the hypothesis that compute and scale are the primary prerequisites for AGI. If Grok 5 launches and maxes out these cognitive axes, it validates the strategy and suggests that intelligence is a property of scale. If a 10 trillion parameter model falls short of broad cognitive competence, it proves that scaling laws suffer from diminishing returns. A failure would indicate that true AGI demands new foundational architectures that cannot be reached through brute force. The launch of Grok 5 will reveal the current limits of computational scaling laws.